In lesson 4-4, we're going to be working on adding and subtracting these rational expressions. So we have the fractions with polynomials on them again, and we're going to add and subtract them. It will definitely be important to remember the properties of adding and subtracting regular fractions. So remember, you always have to have a common denominator. So if you had 1/5, that'd be easy to add to 2/5. That would give you 3/5. If we don't have that, if you had 1/10 plus 2/5, you'd have to figure out how to get this 5 to become a common denominator like 10, which would require me to multiply that by a 2, and I must multiply the numerator by a 2 then as well. Think about that, because if you multiply by 2 divided by 2, you're really only multiplying by 1, so it doesn't really change it. That would leave me with 1/10 plus 4/10 and give me an answer 5/10. Just as in this example I did with basic fractions, it is important to double check if your fraction answer at the end, after you take the sum or difference, has any reducing that can happen. And this one actually does. It would go down to 1/2. So in example 1, they actually give you common denominators, which we're really going to love. So since these still match, we can just say it's x plus 5 over x plus 4, and we are done. Keep in mind, it is not legal to reduce something that is connected by a plus or subtraction sign. So some students might try to cross out, after simplifying in the last sections, x divided by x. You cannot reduce if there's a plus or minus sign connecting that x to a number. So same thing here. We have x times x plus 3. It might not look exactly like this, but think about it. If you multiplied x times x, you'd get x squared, and x times 3, you'd get 3x. So I'm going to rewrite it with the factored version, although it's the exact same thing as the first one, remember. And now I'll combine. I've got 2x plus 3x. That makes 5x. And 1 take away 8 would be -7. And that's our final answer. On the try it, you can check your packet, but note it does have the exact same denominator, so that makes it easier. Now we move on to example 3, where the denominators are not common. So we have x squared minus 1 and x squared minus 3x plus 2. Back to getting the factoring down. We want to factor those denominators to see if they have any factors in common. They both have the x minus 1. So that's going to stay there. But each of the other fractions has one that the other one's missing. So this guy has an x plus 1, but he's going to want an x minus 2. So I'm going to put x minus 2 down here, but whatever I multiply the denominator by, I need to multiply the numerator by. And that's because it's really just multiplying the whole fraction by 1. This side over here needs to be multiplied by x plus 1, because this one has that and he doesn't. So we'll multiply the numerator and the denominator by x plus 1. So I have taken the denominators. They all have x minus 2 in them. They all have x minus 1 in them. They all have x plus 1 in them. They're now common. And I have multiplied each of the top parts. So I had to do the little distribution here with all 4 terms, and it's simplified there. And then I multiplied my 2 through. So now we combine like terms. I only have an x squared here. An x plus 2x makes 3x. And -6 plus 1 makes -5. This will be our final answer, because this top quadratic does not factor, so you can leave it like this. Some steps over here you can look over to find those common denominators, but it's very similar to when you find common denominators with a number. The tricky part is you're working with those factored polynomials. For the try-its, I'm only going to do one of them here. I'll do the little bit more difficult one. These guys both have the x minus 2's. So we're going to say, well, he has the x plus 2. This one's going to want that. Whatever you do to the denominator, you must do to the numerator. And he has the x minus 3. That means this term is going to want x minus 3. So the common denominator will be x minus 3 times x minus 2 times x plus 2. And on the top, I will have multiplied this out. So I'll have x squared minus 3, or actually plus 3x, there we go, combine those, and minus 18, plus, here I'll multiply this 2 through both of those there. I'll have 2x plus 4. So my final answer will be x squared plus 5x minus 16. Okay, we want to do that math correct here. Let me put the 14. There we go. If we take Negative 18 plus 4. Actually, negative 14. Okay, so now, this is exactly like the last problem was, but there's something different with the top. We can actually factor that. So it would become x plus 7 times x minus 2. Because remember, that'd be like a negative 14 when we multiply 7 times negative 2, but 7 take away 2 would make 5. If I leave that over our common denominator, they actually have a common factor. We can reduce it like we did in section 4.3. These cancel. My final answer is x plus 7 over x minus 3 times x plus 2. Now there's not much difference to example 4, but now we're subtracting. So we still need a common denominator. So we have x plus 2 in common. Now I did factor those for you. So again, we're expecting those factoring skills to be decent so you can find the common factors. This guy over here feels like he's missing the x minus 8. And this guy over here feels like he's missing the x plus 4. So I'm going to write my common denominator once, since they'll be the same, and I'm leaving that subtraction sign in here. This first equation would be x squared plus 5x plus 4. I would have to multiply these all out. Remember, you have to do the distribution of all of it. You'd have x squared minus 7x minus 8. Here's where subtraction becomes an issue. I definitely recommend using parentheses, maybe even around both of them, and here's why. This subtraction sign has to be pushed through to every piece. So I will have, on the top, x squared, take away x squared, that'll be gone. Here's where students will mess up. 5x, take away negative 7x. That's actually going to be 12x. And 4, take away negative 8 is actually like adding, so I'd have 12. Then I'll rewrite my common denominator. And this will end up being my final answer, so I'm done. But notice at the top, again, we love to factor. You can actually take a 12 out of that term. You would write it as 12 times x plus 1. You can write either this factored term or this one because it doesn't really matter in this case since there's no denominator of an x plus 1. But if we had a factor of x plus 1 in our denominator, it would continue to reduce. So you can leave the 12 times x plus 1 or 12x plus 12. Either way, we don't have to simplify anymore on this one. Now I'll leave part B over here for you to do. Notice that we're just missing an x minus 5 in the second term. Be so careful that the subtraction sign will apply through to everything you do when you multiply by x minus 5. But over here, we've got 3x, we've got 6x, and we've got x squared. He has a 3, he has a 6. That means this one would wish it had a 2 because it wants to become 6. He's going to need a 6 to match those coefficients. But also, he is x times x. These guys are going to want to have the x times x as well. So he would need a times an x, and he would also need an x. So whatever we multiply the denominator by, we're going to multiply the numerator by. And we would have 2x plus x minus 6 all over the same denominator of 2 times x times 3 times x should be 6x squared. And notice how all of these denominators, if you combine them, have 6x squared. So that would be our final answer. Well, and we actually should reduce it here. Let's reduce it. We'd have 2x plus x makes 3x minus 6 all over 6x squared. And it appears all of them have a factor of 3. So if I reduce all of these by 3, 3 goes into 3 once, 3 goes into 6 twice, we'd have x minus 2 all over 2x squared.